So I've got quite a lot of content. I actually didn't expect 45 minutes, but a little bit more. And I've got videos of some demonstrations, so luckily we'll save time because it's fast-forwarded. Just have one or two questions. Everyone understands English, or should I switch to French? No. Okay. All right. The next question I have is, does everyone know about NSX? Are there people that don't know NSX? No. Are there people that don't know about network overlays? Okay. What I'm going to do in this presentation is actually a level 200, 300. I'm not going to go in deep dive. I have quite a lot of slides, so I'm going to try to keep the questions for the end, if you can, because I have lots of things that will come in later on. So NSX is not just a single product anymore. We are now up to a portfolio with at least 6 different products, different acquisitions and different tools. The last one that we did was buying VeloCloud. So now we also have NSX software-defined WAN by VeloCloud, allowing you to communicate with remote sites. But the main focus of the presentation today is going to be on NSX data center and its extension to the cloud, based on our last version of the product of NSX, which is NSX-T. So this is the third iteration of NSX. So the agenda to start today is first see a bit the definition and the problems we're trying to solve. Talk about the overlay that we've implemented with the videos, then start introducing NSX-T. And after that, I'll go to a demo of NSX-T and how we can leverage the multi-cloud and do micro-segmentation between on-prem, data center, and the cloud. Then we'll dive into the components of the architecture and finish with the different distributed services that are inside NSX-T. So I guess everyone knows about host virtualization, product we've done for the last 20 years, where you can easily deploy multiple virtual machines. So in this case, we've got 2 racks. They have each their own subnets. So with NSX, with vSphere ESX, you can create machines. You can have multiple VMs, and the best thing we have since about 15 years and has probably saved quite a lot of you weekends of work is vMotion. There's no way I will give up vMotion, the fact that you can migrate a virtual machine live from one host to another and go on your weekend normally without maintenance times. But in our case, if we vMotion now, for example, this VM to another rack, and we've subdivided this rack with a different subnet, then we're going to have some issues because the network will not be the same on it. So we'll have a problem is that we're not going to have the communication. Now, when I say second rack, it could be a second data center. It could be on the other side of town. So we have an issue. So what happened is that people started creating stretched layer 2 LANs. Lots of products came out about 10 years ago to optimize this, but this can also cause us some different issues. So what happens if in a stretch environment with layer 2, you have instances of physical firewalls, load balancers, F5s? You're not going to have them all over the place, and you're going to have to route traffic from one side back to the first one to get through the services that you have for traffic north. So suddenly we found ourselves again with an issue with tromboning traffic all across the MAN. And so that was a problem we tried to address with NSX. So what we're going to do with NSX is we're going to instantiate a layer 2 broadcast domain inside every hypervisor. So here I've got some blue VMs on a logical switch. We'll take on each host, we will implement NSX and we'll create a local layer 2 domain. And the communications between the hosts is going to be done via an IP tunnel. So what you see on the graphic here is actually taps, which are the tunnel endpoints on every host. And then our data plane, what we're going to have is keep track of which VM on which host, or the MAC address of that VM, corresponds to which tunnel endpoint. So our two blue VMs are on a logical switch. So we now have an NVDS switch inside the host. NVDS stands for NSX Managed Virtual Distributed Switch. So we've evolved from the vSphere distributed switch to this. And our two VMs will be on this network. You will get all the slides, I promise you. But the videos, yeah, will have it. So at this point, when a virtual machine is moved from one host to another, well, it's going to be encapsulated, or the traffic between the VMs will be encapsulated through this tunnel. So that's our overlay, really. So coming back to the VMs that move, our data plane will update the settings. So now we know that the VM2 is now behind the tunnel endpoint B3, and we're going to be routing again via the IP tunnel or the overlay the traffic between the two machines. And as you see now, the physical network, subnet A and B, can be still different. We'll still have connectivity between the VMs, and they will be able to move from one side to another. To get this working, because we are encapsulating the traffic, we have only two requirements on the physical network. We need IP connectivity, and we need traffic to be at least 1600 as an MTU. Jumbo frame is recommended, but not everyone is doing that yet. So after that, all the communications work. The overlay that we use with NSX is called Geneve. It's the generic network virtualization. It's a follow-up to the VXLAN, but it allows more headers, metadata in the headers, and flexible MTUs. So for our requirements, IP connectivity and 1600 MTU, you can use whatever physical network you have. So if you've got old switches, if you've got new switches, if you're spine leaf, if you're different constructors, routing, whatever configuration you have, it works. So you don't have to reinvest in new switches. Only invest in switches when you are near capacity or you're out of support. No need to change your lower level of the infrastructure. So if your infrastructure is multiple vendor or multiple generation of switches, it doesn't matter to us, as long as we have this IP connectivity and the MTU. One of the other benefits we get from the virtualization of the network with the overlay is that you're only going to have the logical switches for those virtual machines on the host that have them. We can reuse IP ranges. So if you later on want to have an application in a shell for quality assurance or whatever for testing, you can just copy the VMs with the network. So there's no address of conflict, and we'll see how we can manage afterwards the routing. And you can all do this either using the user interface. So NSX is now using an HTML5 interface. No more Flash, no more Flex. That's done. It's a completely separate management platform, so you don't have to go via the vCenter to do this. And it can all be automated. So after that, it's using REST API commands. So you can use PowerShell, Ansible, Terraform, whatever. You can automate it. So I've got customers here in the Suisse romande that have deployed the whole NSX with a PowerShell script. Others have used Ansible. So whatever you fancy, within limits, you can use to deploy. The next step after just managing this layer 2 broadcast and networking is that we're going to be able to do firewalling straight on the VNAC of the virtual machine. So it's not done inside the virtual machine, but on the network card. So after this, we can really filter. We can do macro segmentation, stopping subnet 1 to talk to subnet 2, micro segmentation within the same subnet, so that the database server cannot talk to a web server, only the app server can talk to the database, and so on. And all those rules are managed centrally in the management of the NSX. There. You can group VMs by multiple, by IP set ranges, by machines. You can use regex commands to group those virtual machines for those rules. But with NSX, we wanted to do more than just layer 2 and micro segmentation. The idea is to have all the different network services inside the software. So switching, routing, load balancing, VPN, firewall, connection to the physical world, layer 2 bridging. If you've got hosts that are still physical and you want them to talk to virtual machines, NAT, DHCP, and all the metadata. We also have a small IPAM for this specific use cases. If you do containers inside NSX, you can consume this also. So the best thing about this version of NSX, and I think it's a game changer compared to the previous version, which was NSX for vSphere, is that we support multiple platforms. So you can manage ESX hosts running NSXT. You can have clusters with KVM hosts. So we support Ubuntu, Red Hat, CentOS, SUSE. We have an agent that deploys and manages this NVDS on those Linux machines using Open vSwitch. And with the same agent, actually, we can also protect Linux bare metal servers. So if you've got SAP HANA running on a SUSE 12 and you want to protect it with microsegmentation, you can do it. If you run Oracle database on a Red Hat machines, you can do it. We support workloads, they may be VMs, containers, Kubernetes, OpenShift, OpenStack, bare metal agents, multiple vCenters. So you're not bound one NSX manager to one vCenter. So we just consume the vCenters for compute nodes. And it's the same code that is used actually to also extend NSX in the cloud. Single source code from which we compile the API, and then we can deploy virtual machines on Azure, on AWS, or what we call VMC, which is VMware on AWS. So that's ESX servers that run in AWS data centers. All this with NSXT with a single source code. The use cases, I'm just going to briefly point to the different use cases. So it's security, naturally, microsegmentation, integration with firewalls from third parties, service insertion, cloud-native applications. So we still get security, routing, load balancing functions, automation. Customers are wanting to move to really automating the deployment of the infrastructure, Terraform, and the multi-cloud. It's the only slide I'm going to do on the use cases because I've got a slide deck and I can talk for now just on the use cases, and we don't have that time. So the first demo I want to do, and it's a recorded demo, so I know it works, is actually an application we've deployed called planespotter.nsxcc.net, and you can test it right now if you want. It has 6 front-end web servers that are located in AWS and in Azure. And the database for the application and the data itself is on-prem in our data center in Palo Alto. We've got connections between our on-prem network and AWS here using VPCs and VNet going to Azure. So when you hit this web page, you will be on one of those sites and the data is kept inside. So let's have a start of a look of the deployment. What we have here is actually the graphical interface of NSX. This is not the last version, it's the previous one. So we have the manager nodes, the controllers, which is our control plane, the hosts, the edges. And what we're going to see is here the public cloud gateways going to Azure and AWS connected to different VPCs. So when I look into these clouds after having, that's the same video, moving on to the next one. So with NSX, we now also have a search function. So when you want to quickly find your application for Plane Spotter, you can do a query. It will bring up all the devices that have the term Plane Spotter in the infrastructure based on the discovery it has done in AWS and in Azure. And as we see, we've got different tags on the different machines. Here we see this front-end web server. It's got app tier and description of these tags. So the next step, based on these tags, is that we're gonna be able to group them. We've got different groups for the front end based on the tags, so you can use IP sets, VMs, and the tags. And we see that in this front-end group, we've got the 6 machines that have been discovered via the inventory. So what we're going to do afterwards with these 6 machines is we're going to create some firewall rules here. Different sections. We're going to open the Plane Spotter rules, and we have, using the tags, we're going to show here, for example, for the app layer, the source being based on the tags, database, MySQL, and it's on the distributed firewall. So you don't have to be a specialist of AWS security or Azure security. Just from the single pane of management, you'll be able to deploy the rules across the multi-cloud environment. Is this something that's looking promising? Right, now to build up to this kind of demo, I'm just gonna go now over the NSX architecture. And the next slide is gonna be loaded. So I'll start small here on the data plane. So what we have is an ESX host with our NVDS switch. On top, we've got our VMs. So this NVDS switch is a new kind of switch that we do. It's managed by the NSX and really allows us to work on very high performance and low latency traffic. So this is a switch that has also been optimized for telcos, for everything that is G5. And we can push up to 8 million packets per second on a 2 CPU server. So depending on the requirements of the customers, if you do network function functions, NFV, you can use NSX for this. So the second one and the extension is now to have NVDS on KVM hosts. So it's going to be an Open vSwitch implementation of the switch. It has an agent. And on top of that, now we also have container workloads. So if you're using Kubernetes, OpenShift, OpenStack, we upstream our code for these integration with plugins. So whatever OpenStack solution you use, you can consume under it an NSX environment. Just talking about the traffic and our NSX edge. So the edges, and I will come back on them at the end of my presentation and really explain more about them, but they are the on-ramps to the physical world. So when you have traffic going from one VM to another in the overlay, when it leaves the overlay for the underlay, so the physical world, it's going to be done via these edges. These edges, they exist in two formats. You can either have them as a virtual machine, or if you need performance and high convergence in case of issues or network issues, you can also have them as a bare metal server. Using the same agent we had for the KVM, we can now do also security and microsegmentation on bare metal servers. So as of the last version, we support Ubuntu, Red Hat, CentOS, and SUSE. The extension in the cloud. So this is all what we call NSX Cloud. So we're going to deploy an NSX Cloud Gateway in Azure or Amazon, and you will consume virtual machines on these clouds that have the agents inside of them. We don't have access to the lower level of these network infrastructure, but in the machines. Yeah. Google, don't know yet. We've got quite a lot of things planned in the future, but not as of today. The next layer above is our control plane. So we have an even number of controllers that replicate the data between them. So this is our supervisor module. They will learn which MAC address is on which host. When you have a new machine that is connected, it will inform the controllers. If you have a VM that wants to talk to someone else it doesn't know, it will connect to the controllers. On top of that, we've got our NSX Manager cluster, on which you connect using a cloud management platform, internal, or REST API, Python, Terraform, whatever you want. And using those REST API, we have multiple connections. So we've got our NSX container plugin. So if you use Kubernetes and you want to automate the deployment of a new namespace network, load balancer, it's all done via this plugin. So in the last version, we've consolidated the control cluster and the management clusters. So it's a single set of 3 VMs that do all these things. Okay. So let's go a bit through the NSX Manager cluster and how it works. So the first thing, well, you connect to the manager. It will connect to all the different hosts you connect. So you can connect straight from the manager to an ESX host, or you can jump via a virtual center to manage clusters. So in a small environment, you could just add ESX host or KVM host straight into the manager. So this is done via the user interface or via the API. We're going to keep all the user information persistent in this dynamic database, and all the queries will be done here. So if I want to connect a virtual machine on a network, it's going to be via the manager that we're going to configure. So I've got my virtual machine 1. It's VNEC. I'm going to create a logical switch. The short name for this is LS, naturally. We like to keep those small names in the documentation. We're going to create a logical port. The good thing is you can also really define the port, so you can edit, create it, you can change it. So you can put a descriptor as well in the port. And then we're going to do the connection. Now this is a desired state. It's not yet on a physical network, but at least it's saved to be deployed. So our manager control cluster is going to talk to the functions of the control cluster. It will push the stateless configuration forward, and these will be pushed towards the hypervisors. Just deploying NSX software on a hypervisor doesn't mean it will communicate. You have to instantiate and transform a host into a transport node so that they can communicate between them. It also gives you a facility of creating logical spaces of all the hosts that can communicate together. So you could have a production namespace, I would say, or logical space, and you could have a lab space, and you wouldn't be able to connect logical switches from one to the other. So the controllers will disseminate the topology when you create microsegmentation firewall rules as well. It will be done in a controller, and these will be pushed out to the hosts that have those virtual machines. So if I create a set of rules to protect one virtual machine, they will be only pushed to the host that has that virtual machine, not the others. So I send my configuration, instruct the host 1 to attach the VNIC 1 to the logical switch. So we do that. It will reply, give the information, retrieve the MAC address, update the table so that afterwards we can communicate with the virtual machine. And it will tell the other taps that we have a logical switch 1 on that host. That's important. So, now I'm just going to have a small demo on how to deploy NSXT. It's not as complicated as it sounds. In this demo, we've got 4 ESX hosts. 2 will be used for the management and the edge infrastructure, and we've got 2 hosts with virtual machine 1 and 2 on it. So the first step is to deploy the manager cluster. So this is accelerated so that you get out in time for lunch. So the idea is to import the unified platform. I'm only going to deploy for the demo 1 and not 3. You enter the information where it's going to be put. You enter the IP addresses. You give all the information about connectivity, passwords, and so on. The good thing with a recorded demo, there are not many mistakes. And it goes faster than physically if you do it at home or in the office. So once the manager cluster is deployed, and deploying goes faster in the video, we'll be able to start configuring and logging in. So you see at the moment we are in the vCenter because we deploy it there. The manager virtual machine can be also deployed on a KVM infrastructure. So the next step is to connect on the HTML5 interface of the NSX manager. And we've got the interface, and the first thing we're going to connect is actually connect to a compute manager. So we're going to enter the information of the vCenter. This allows us to simplify the deployment of the different virtual machines and configurations. But you could decide not to do it and go straight to the host themselves. So import the certificate, the thumbnail, and now we've got our vCenter connected to our manager. You can manage multiple vCenters. At this point, we're gonna deploy the controller. So in a newer version, actually the manager has the controller himself. So this is something that's gonna be skipped if you do it now with the latest version. We always have the information and the status of the manager and the disk space and so on. So we know all that information makes it simpler to troubleshoot. So NSX controller 1. In this demo, we only deploy 1, but in a production, you would need 3 to make sure that you've got enough capacity and fault tolerance, and you'll put anti-affinity rules on those virtual machines. Hop. Right. So now we're going to create a transport zone. So the transport zone is the way the different hosts will communicate. We'll create an overlay transport zone. So all the hosts that are part of this overlay of this transport zone will be able to communicate. So in the fabric, we're going to go to transport zone. We're going to create one. We'll call it overlay transport zone, TZ. And we will deploy NSX on the host and connect them to those transport nodes. As you see, we use the vCenter actually to decide which host we will deploy NSX on. So it's gonna configure NSX and deploy it. We have pre-provisioned an IP range pool for the tunnel endpoints. So that was done in between. And we'll have this connectivity. So here it's deploying NSXT and we'll create the tunnel endpoints so that the host can communicate between each other. Now, for our virtual machines to communicate, we're going to have to create a logical switch. Next step, we go to switching, and we'll create a new logical switch. My logical switch. The configuration of the logical switch is done in an NSXT. It's not done in vCenter. I'll come back on some of the configuration in a moment. So we see that this machine here is using an overlay IP range. In vCenter, when we look at our virtual machines A and B, we'll be able to map them now to the new logical switch we created. So take virtual machine A, we're gonna go click, browse, and we see that we've got our new logical switch in here, and we create the connection. So VM A is now connected to this logical switch, and we do the same with VM B. All right. Oops. So traffic, when it flows from the first virtual machine to the second one, well, we'll have the traffic come out of the virtual machine. We'll look up where we have to send this packet. So the packet for the VM5 on either side should be sent to the TEP equivalent of C1. We'll encapsulate the traffic. Reason why we need bigger MTU. We'll transit, and it will be decapsulated on the other side. It's as simple as that. If we do broadcast or multicast, and we've got different subnets in the racks, we'll be able to actually optimize the traffic flows by using one proxy in each rack to distribute the traffic, saving us on network bandwidth. So here the traffic is being distributed to the proxy in each of these different subnets racks before being distributed. Let's talk now about the network services, and we've got those two virtual machines. Well, now they are called VM1 and VM2. They're on different logical switches, so LS10 and LS20, and we want to create a router to connect these two machines together. So we create a tier 0 router, call it my router. At this point, we're gonna create downlink connections from the router to the different logical switches. So I select the downlink, I select the network, I can enter here the IP address of the router port connected to LS10 and the equivalent for the second one. So these are downlink connections. enter a 10.16.20.1 network. And we'll be able to test the connectivity between those two virtual machines. So on one side, we'll have a ping, and on the other side, we'll actually have a trace route that will give us the information, also showing you the ports of the router. It's pretty easy, actually. How is this connection done? Well, this connection is done with a function called logical router. This is not a virtual machine. This is an instance that is running inside the kernel of the hypervisor. So we're gonna, if you have a single physical host, well, it will be inside a single host. If you have multiple hosts and you've got a network on the other, you'll have the same router on the other side. So this is the flow of the information. If we have logical switch 10 and logical switch 20 on different hosts, we'll have the same router in virtual in the kernel. Routing will always be done at closest point from the source code, so the source point. So it's going to always be routing done inside the host local. So traffic flow will be asymmetrical. It's important to understand this. Traffic will come out from VM1, will be routed, put into the transport tunnel for the logical switch, and distributed on the other side. Traffic flow coming back. Yes, there's an error. The traffic doesn't go back to the router. It goes to the VM1. Is done the other way around. So this is an asymmetrical routing. Where it gets really interesting now is if I go and do a trace route or a trace flow of this traffic, it will document for me all the paths from VM1 to VM2. So we see clearly that the traffic is coming out of the VM1, goes through a distributed firewall, is now on the logical switch 10, hits the router, is routed to logical switch 20, is still on ESX1 here, and now it enters the tunnel, comes back to the outside, and is being distributed. Gives us really the visibility of how the traffic flows. And at every one of these points, you can look at the documentation and pull up information, giving you the tables and the configuration, the speed of the ports, and so on. Really gives you the visibility on how your traffic is flowing. So the thing with asymmetrical routing is that there are some functions that we cannot do if we only have one way of the traffic. Anything that requires a stateful service, like firewall coming in, north-south firewall, load balancing, NAT, DHCP, well, these functions cannot be distributed across the hosts. We will distribute those functions actually in those edge nodes. So those edge nodes I mentioned early on can be either VMs that will have the connectivity to the physical network or physical servers. So functions will be just distributed across the environment and in these edge nodes. To improve performance, we've used the Intel DPDK libraries. This really allows us to push a lot of bandwidth. So we can push over 50 gigabit on bare metal servers. These can also be for fast convergence in case of failure, and we've got special drivers that will consume specific Intel network cards and some others. And we make sure that we've got enough CPU resources attributed to those services and the memory. This allows us to push really the traffic above. For normal traffic, we can use virtual machine edge nodes. We have less throughput, takes a bit more in convergence in case of failure. So it really depends on what you want to do. We've got this flexibility. So if we take our sample from beforehand of the logical view where we've got in our infrastructure, at one point I need to connect to the physical network. And this physical uplink is not going to be on the host, it's going to be connected to the edge node. So if I do a representation, suddenly I'm going to have a huge edge router. But this is actually distributed. It's distributed in a different host, and we have an instance running on these edge nodes. Here we have our physical uplink connection. So east-west traffic is always distributed, but if we want to go north-south, we're going to have to connect our routers to the edge nodes to the physical network. So we set up a dedicated internal logical connection. We take care of this management automatically for the traffic. So let's see again how we do this. Well, on our T0 router, we're going to create now a new interface. We're going to add actually an uplink, and we're going to consume actually a logical switch, a VLAN. We select which edge node we're going to use, and we're going to use a VLAN for the traffic. Again, we enter an IP address for the outside world. Hop. And we've got the connectivity to the physical world. Now we can use dynamic routing, you can use static, you can decide what you want to push out, what you don't want to push out, and so on. Let's look back now to our trace flow from the virtual machine 1, for example, to a physical server on a network. So we're going to use an IP address here. This will give us, again, all the information on how we flow. Going faster than the video, sorry. And again, here we've got the router, but we hit the router, we're still inside the router until we get to the edge, through the tunnel and to the physical network. So we just talked about logical routing, but we have added a lot of other services. Gateway to the physical infrastructure. We use BGP for the physical infrastructure. We can use equal cost multipassing, so you can have multiple redundant paths for the traffic north-south. We've got functions, load balancing, VPN, NAT, firewalling. So the firewalling can be distributed across all the hosts, or we can also have firewalling north-south. We've added IPv6 support. IPv6 being a very big beast, it will come into different phases. We've started with IPv6 addresses, routing, and we'll add more services as time goes by. We've got now guest introspection. So if you've got VDI environment and you want to make sure for using different tools from antivirus providers inside guests. We've got east-west traffic service insertion, so we can use different firewalls from Checkpoint, Palo Alto, Fortinet. North-south service insertion, if you wanted maybe to add a F5 in a path. We have DHCP server for the different networks. And we now added also layer 7 app ID based firewall for desktops. So lots of different services coming into NSX. So now we've seen the different use cases, networking, security, automation, visibility. Have to remind you that we are multi-hypervisors. Workloads can be containers, virtual machines, bare metals, and the extension on-prem and hybrid cloud, multi-cloud. We have a one-day event in April in Lausanne where we do labs. So I'll present and go through the different sections. You get your hands on. We do the lab remotely. It's all nested. So if you want to come to this event on the 12th, see us at the booth downstairs. If you want to learn more about NSX, I highly recommend the hands-on labs. You can do them at any time, tonight or not, tomorrow, not tomorrow, tomorrow Saturday, on Monday, if you're back at work, just head to the labs HUL VMware. So, there you are. Do we have any questions? or not.
Yes, it was just for alliances that sniff network for analysis, threat intelligence. Before we connected it directly to the VDS with a promiscuous mode in order to sniff all the traffic. Now the traffic is completely encrypted between the VMs.
Not encrypted, encapsulated.
Yeah, but will it still work with that kind of appliance?
We have taps. We can have a redirection of some of the traffic, yes. Some. I don't know all the functions of the traffic redirection, but we have functions.
And the second question I didn't understand with bare metal servers. So you also support Windows?
We support Windows today on Azure. We have an agent that deploys inside Azure Windows machines. Can't say more. Yes.
For bare metal controllers and Edge, do you need socket licensing?
For bare metal servers, so to do microsegmentation, no, the controller is a virtual machine that can either run on a ESX or a KVM. No, you don't have. If NSX is not on that ESX host, you don't have to license that host. It's really only the host that communicate. The bare metal physical server that is for traffic as an edge node doesn't have to be licensed. It's only the hosts that are running NSX. Yes?
What kind of tools are available to see the performance on traffic going in, out of the edges? You have,
okay. Yeah. At the start of the presentations in the different products, we have a tool which I didn't show today. We've got Network Insight here. Network Insight is a tool that most of our customers that invest in NSX take as well, but it's a tool that also we've got customers that have invested in ACI look into. It's a tool that will take IPFix flows from the sources, and it will give you a diagram of the flow with information from the overlay and underlay, because we connect to Cisco, Arista, Juniper, Checkpoint, Palo Alto, and it will give you a diagram of which flow goes to which flow or which flow to which source. And based on what it can show you, actually, it will also allow you to get out the information, how you can secure it with microsegmentation. Based on that, you can export the rules and then apply it to one app on NSXT and start your microsegmentation of your environment step by step. So that's the tool that will give you all those graphics and is really an operational day 2 tool that goes with NSX. More questions? Oh, yes.
On the last question, so in case you needed that information outside of the NSX world, is that something which also can be delivered elsewhere by API, via log delivery, classic kind of net flow?
So any host, VMware host that has a virtual distributed switch or the NVDS can output this information using the IPFix format. So if you can interpret this, it's just like a net flow analysis. You can do that.
Do you have customers that do that already, or do people mostly get what they need from Network Insight?
We've got most customers actually use Network Insight. Even if some of these customers actually don't have NSX, they use Network Insight to get this information. Yeah. Now you can also output information to syslog, but it's always difficult. So that was one of the acquisitions we did about 2 years ago, Arken. So the tool is pretty useful to have a quick view. We also have actually security officers that like it because it will, for example, show you new traffic that's never been seen on a network in the last 24 hours, or that new VM that's connected, or so on. You had also a question.
Will the NSX deployment migrate legacy virtual switches, VDSs, to NVDSs?
So we've got a process, actually, you can do it using the user interface or so on. It's a two-step process, or two steps, one after the other. So if you want to move from a VDS to the NVDS, the idea is also to migrate the vSphere kernel ports using VLAN based, and you migrate them. But yeah. So even if you have a host where only two interfaces, you can migrate to NVDS.
Licensing for cloud gateways?
There's no licensing for the cloud gateways. We have a licensing, I think, on the number of instances you run inside Azure or AWS, a certain ratio of 15:1, I think, or something like that. I can look it up afterwards. Yes?
If we have users on physical or laptop workstation, do we do identity-based firewall with NSX or do we do something else?
Not yet, because we don't have that agent out for Windows at the moment. It's more for inside the infrastructure, inside the virtual machine that you're gonna have. You deploy that agent inside a virtual desktop. As soon as the user logs in, he will be authenticated with the Active Directory. Based on his group, you'll apply at that virtual machine microsegmentation rules.
Is it coming?
I don't know. Above my pay grade, unfortunately. Lunchtime!
Yes, seems so. Thank you for attention.
Thank you very much.
Thank you for the presentation.